next speaker. So our next speaker is a doctoral researcher at NIST, Nara Institute of Science and Technology. And it says that if you want to know somebody more, you should go to his social network. So I allowed myself to go to his Facebook, and I found out that our next presenter is a Kung Fu master. And he studied in Tanzania, then in India, then in Japan. So I can predict, like, without machine learning, that his next position will be like Silicon Valley, West Coast. I don't know. So please welcome Gemma.
Yeah, thank you. So good afternoon and nice to meet you all. So I'm not very good at public speaking, but I'll not let that distract my presentation. So with a short introduction, my name is Gemma David. The last name is difficult to pronounce, so I'll ignore it. Yeah, I'm a Doctor of Engineering student on my final year at Nara Institute of Science and Technology at the Laboratory for Cyber Resilience. So as the title says, assisting smart device users from falling victim to classic attacks. So my research is basically in small devices, IoT devices and smartphones. And I try to focus on these devices because most cyber security solutions, they work only on desktop environment. And they don't work in smart devices due to computational power. So I'll start with the background. And so there are so many cyber attacks. There are hundreds of them, or maybe thousands of them. But this phishing attack is very classic, and most of us we are familiar with, and also man in the middle. So phishing, for those who are not familiar with, is a fraudulent attempt to obtain sensitive information. For example, password and username, or credit card details. So by an attacker disguising to be a trustworthy party, let's say someone disguised to be a Rakuten company, and send you an email which basically looks very authentic with the domain name which is similar, but he might send you a link and try to make you panic, like someone tried to access your account, so please click down below to verify. So that moment you do that, you enter your password and username, they are gone. So also man in the middle. This is just the way the name is. A person sit between two parties, listen your communications. So there are so many techniques for man in the middle, but the one that I'll present is called RP spoofing, or RP poisoning. Yeah, so recently there's an increase of our smart devices. Billions of devices have been increased. So this increase of devices has been associated with some issues. Phishings are becoming more sophisticated. Unlike back in the days, nowadays phishers, they would just clone the real website. So it is very difficult to predict whether it's real or not, especially if you don't see the URL. But even the URL can be authentic, but still it can be forged, even with HTTPS. So the attacks are presented with the high credibility web pages. And also other issues, as I've said before, is the money in the middle or money in the browser. So these two attacks is just a sub-component of my research. So I chose them for this kind of audience. So it will be just short and simple. Yeah, so as I've said, I chose the small devices for the reason of low computational power and limited features. Yeah, so there's a high chance of success in small devices. And also, as I've said, more solutions focus on desktop computers than in mobile devices. In mobile devices, for example, anti-phishing plugins, they don't work developer try to omit those plugins due to the computational power issues. And also, some research says that mobile devices users are more vulnerable, 3 times more vulnerable than desktop users because they are online most of the time. So yeah, there's a high chance of interacting with attackers. Also, these limitations is a small screen size. Sometimes you can try to see the URL, maybe it's truncated, so you don't see the full URL. So that can fool you. Or some phones, they cover the entire screen, so you cannot see the URL. And yeah, also you cannot see the SSL certificate. And moreover, there's a problem of single point of failure in man-in-the-middle attacks. So as I've read into many research, most solutions for man-in-the-middle attacks, which works in desktop, they also have a problem with a single point of failure. The device that control the IRP spoofing attacks is centralized. That means if it is compromised, the entire network is compromised. Yeah, so popular method for these attacks like human exploitation, as I've said, example of phishing, and also system exploitations, such as password cracking, private escalation, or zero-day attacks. So the objective of this component is, assistive techniques for smartphone users against phishing attacks and RP spoofing. And also, I'll show the evaluation of which some people fall victim for phishing, but we certainly don't know whether it's a knowledge or just carelessness. So the hypothesis was a user can be knowledgeable or aware of phishing attacks, but still fall victim if he doesn't pay enough attention. And also, a person with no knowledge can be able to figure out the phishing attacks if he pays enough attention to the details and something ambiguity to the web page. Yeah, so this try to solve, the contributions try to solve the computational power issues for those attacks I explained before. Yeah, and these are the research questions, which is a kind of repetition. And SPOF refers to single point of failure, so I'll use that often. So the proposed solution for phishing attack is we developed an application, native Android application called UnphishMe. So this is a simple and cost-effective Android app solution which inject fake login credentials into a phishing site. So normally when you have a web page and you put dummy password and username, definitely you'll be rejected, right? So, but for phishing, it's different. That's the main weakness of phishing sites. Whatever you're putting, because they want to fetch your credentials, whatever you're putting there, they'll just accept you and tell you that you are successful login. So they will tell you to proceed with other stuff like credit card information. Yeah. And so for the ARP spoofing, it's, we proposed and tested a lightweight and scalable immune to single point of failure technique for protecting those devices. So I'll both explain this in a while. So in a study conducted, so I'll explain a little bit about UnphishMe. So it enables a mobile device user to create a fake login. So this was just for making a user aware, but not necessarily a user create a fake account with fake login credentials. But the application itself, it can generate a fake username or fake email address and password. Then it mimics the user login procedure like a bot. So it can work in the background, and every time you open up a web page, it will hunt for, if you're, for you, if you have used HTML programming, those user ID tags and password tags and submit button tags in the HTML tags. So the bot will just hunt those tags and inject the fake login credentials. So the moment you are logged in, it will go if you are successfully logged in, and it will go through several iterations, then which I'll show in the logical diagram flow. So it will be able to notify a user to be alert of the page. Also, if you are logging successfully into a page, normally the www.something will change, right? Maybe an additional page, because you will never be on the same URL. So it does monitoring the hash code. So it computes the hash code of the initial URL when the page is loading and listen to what kind of HTTP URL connection status code, and then it makes decision on whether the page is fake or not. Yeah, so it's fully automated, and it can run in the background, and it hunts for login field, and it automates the user login procedure before actual login, and it iterates the login procedure for assuring an attacker did not disguise the first login to behave legitimately. So in this case, if an attacker realizes your technique, he might fake the first attempt to be rejected, for you to have an illusion that this can be real web page. So it has a several iteration to wave off that kind of trick. So this is a logical diagram flow. So there are two parts on the main logic is here. Is it authenticated? Yes or no. So from there, if it is true, then that's the start of the problem. So to check monitor the hash code changes, and also listen to HTTP status code for web server. Sometimes they employ HTTP status code 200 for successful, and for rejection, sometimes it's 401 or 302 for redirection. Yeah, but not necessarily these codes can be, it depends on the language or technology used to implement that web server. And if it is false, then it also checks to make sure the URL did not change. And if it didn't, to make sure it is not disguised by an attacker, it goes through other iteration until it become constant, and check for this status code, which is rejection or forbidden or out of service, and then it give an alert to a user. It doesn't block a user from proceeding, but just give an alert to be conscious about, to make decision by himself. So there's a login automator in the app and the response interpreter engine. And then, send the login credentials, compute the hash code, and back again, and compare the response. So as I said before, we got very minimal CPU and memory usage, which is less than 5% for the entire simulation. And we tested about 50 websites from Fish Tank. It was 96. Actually, it was supposed to be 100 because there's no reason for this not to work. But some sites, they employ Flash. They don't use HTML tags, so this won't work. So for securing the computational power issues, so also we have this problem, RP poisoning attack. First, for devices in a local area network to communicate, they have to create a MAC address table, which associates MAC address and IP address. So this device, they don't use IP address. Instead, they use MAC address. So they create a table, but the problem with this table is volatile. Every time you restart the device, it also erases the entire table. And it's very prone because the RP protocol does not give a feedback for a subsequent request. So that means if I ask who has this IP and someone reply, who has this MAC address for this IP, someone replies to me, I won't be able to tell whether this is authentic or not, because that's the weakness of RP architecture. So I'll go straight to because of time, to the simulation. So here we have device A and B. So device A, Yeah, and the unknown device and an attack over there. So every device has a IP address and MAC address. So device A wants to know what MAC address B has by asking what is the MAC address for this IP address. So normally A will broadcast the packet. So whoever has that MAC address will reply. But also an attacker can reply if he intercepts this packet. So B will reply his MAC address with association with the IP address, and then all the devices will update the RP table, including the B MAC address. But unfortunately, attacker can try to intercept the packet and replace the MAC address of B with his own MAC address. That means the communication will be through A and the unknown device and attacker. So A will think of that he's communicating with B, but actually he's communicating with an attacker. An attacker can B relay the message. That's why we call man in the middle. He can B forward the packet to B and take a response and forward to A, but he can read and decode the information. So what we did to solve this problem, okay, the time is up, but I'm just finishing this. So we created a permanent RP table instead of using the volatile. So because taking advantage of smart devices, they have SQLite database. So when these devices, they broadcast to each other, the MAC address table is saved into SQL database. So it creates a copy of these tables, and it's saved permanently in the device. So next time when they want to communicate, actually, if an attacker tries to communicate, the device will consult the permanent table in their, so attacker tries to change the MAC address, and then the other device will ask if this MAC address is legitimate and it is known in this network. So if it doesn't and it's not in the permanent tables of each devices, it will be dropped. So I'll end up here because of time. But thanks for listening. So if you have a question, please.
Thank you, Gemma. Oh, I think your next slide is like just conclusion.
Yeah, there was something else.
Okay, but well, maybe people will ask questions, so you can give you a chance to say something. So if you have some question, please raise your hand. I will go left to right. It's okay? Okay, then we go right for left.
Hello. So my question is like, how is your research is like supporting for GDPR? Because like we know GDPR is like every people, like every company or every security or internet, it needs like to be like aligned with the GDPR. And then how is your research is aligned also with the GDPR or supporting GDPR? You know the GDPR.
Can you enlighten me with the GDPR?
It's a global protection data for like it's starting from the UN. I'm sorry, it's from the AU, European. So they want to protect the customer's data or anyone who like assign with their company. So it will like protecting their data from breaching data.
Okay.
That kind of like law or policy that currently like every company who dealing with the European company, it needs to be like handling with that. So you remember that if we are signed to the internet, and then they will like, is it okay to use your data for cookie? This data, this website is using cookie. That's part of the GDPR.
Okay.
So do you like your research will align to that protecting data?
Yeah, I can. Well, I'm not very familiar with the goals of GDPR, but I think it should cut across, because the main goal for my research is to protect communication, right, between users. and also to make sure user makes security conscious decision. So if that is aligned with GDPR, then I can say yes.
Is it okay? Thank you. In the interest of time, maybe we can ask questions for during the networking time, because we need to move. Sorry, is it okay?
Yeah, actually, if you have time, you can check in the Google Scholar my paper. You can just type my name, Gemma David, and if you want to read the paper in length, you can just check it.
Yeah. Okay, thank you very much. For those who has questions, please ask him directly during the networking time. We are sorry for that. So we get ready for the next presenter. He's a Vice Senior Manager